Welcome to Lecture 4, Understanding Quality Attributes of Software Architecture. This is your Professor Atif Fareed Muhammad. We will be learning in this lecture about architecture and requirements, functionality, quality attributes considerations, specifying quality attribute requirements, achieving quality attributes through tactics, guiding quality design decisions, and in the end we'll summarize this in detail. So the software architecture and requirements, let's look into this with a gaming or a gaming portal, gaming solution, a gaming computer system creation. Imagine that you're playing your favorite computer game like Minecraft, Fortnite. Behind the exciting graphics, fast-paced action, and interactive worlds, there is a complex system called software architecture. Software architecture is like the blueprint of a game outlining how different parts of the game work together. For example, think of a game when you can build your own virtual world. The architecture would include parts like the game engine, which handles the graphics and physics, the user interface, which lets you interact with the game, and the server, which allows you to play with friends online. Each of these parts needs to work smoothly together to create a fun and seamless gaming experience. Now let's talk about requirements. Requirements are the specific features and functions that a game needs to have to be enjoyable and successful. For instance, if you are playing a racing game, a requirement might be that the cars can accelerate, brake, and turn realistically. Another requirement could be that the game has different levels or tracks to race on. Requirements also include things like how many players can play at once, whether the game can be played offline or online, and what kind of devices it can be played on, like a computer, tablet, or gaming console. Gathering and understanding these requirements is crucial because it helps the developers know what to build and how to make the game meet the expectations of the players. To make sure that the game is fun and works well, the software architecture and requirements need to work together. The architecture provides a structure and the requirements provide the detail of what the game should be and should do. For example, if a requirement is that the game has a multiplayer mode, the architecture needs to include a server that can handle multiple players connecting and interacting in real time. If a requirement is that the game has high quality graphics, the architecture needs to include a powerful game engine that can render detailed images and animations smoothly. By combining a well-designed architecture with clear requirements, game developers can create exciting and engaging experiences that players will love. Functionality. Functionality is the ability of the system to do the work for which it is intended. Functionality in a computer game refers to how well the game works and how it allows players to interact with it. Think of functionality as all the things you can do in a game that how smoothly those things operate. For example, in a game like Minecraft, functionality includes being able to build structures, gather resources, and explore the world. In a racing game, functionality might include accelerating, braking, steering your car, and competing against other players. Good functionality means that all these actions work as expected and are easy to use, making the game enjoyable and immersive. Imagine you're playing a game where you can customize your character. The functionality of this feature would include being able to change your character's appearance, such as their clothes, hairstyle, and accessories. It would also involve saving your customizations so that your character looks the same every time you play. Another example is in a strategy game where functionality might include building armies, managing resources, and planning attacks. If the game's functionality is well designed, these functions and actions will be intuitive and responsive, permitting you to focus on a strategy rather than struggling with the controls. To ensure great functionality, game developers need to test the game thoroughly. They check that all the features work as intended and that there are no bugs or glitches that could disrupt the gaming experience. For instance, if you are playing a game where you can jump over obstacles, the developers would test to make sure that the jumping mechanism works smoothly and that you can get stuck or fall through the ground. They also gather feedback from players to improve the functionality and add new features that make the game even more enjoyable. By focusing on functionality, game developers can create games and are not only that are not only fun but also easy to play and navigate. Now let's look into quality attributes considerations in computer gaming as our running example. When creating a computer game, developers think about more than just what the game does. They also consider how well it does it. These are called quality attributes and they are crucial for making a game enjoyable and successful. Quality attributes include things like performance, reliability, usability, and security. For example, performance in a game means how smoothly and quickly it runs. A game with good performance will load quickly, have smooth animations, and respond instantly to your actions, like when you press a button to jump or shoot. Reliability is another important quality attribute. This means the game works consistently without crashing or freezing. Imagine playing a game where you are about to defeat a tough boss, but suddenly the game crashes and you lose all your progress. That would be frustrating. A reliable game minimizes these issues, ensuring that you can play without interruptions. Usability is about how easy the game is to learn and play. It includes things like clear instructions, intuitive controls, and a user friendly interface. Good usability means you can start playing and enjoying the game right away without getting confused or stuck. Security is also the key quality attribute, especially online games. It ensures that your personal information and game progress are protected from hackers and cheaters. For example, if you are playing an online game where you can buy items with real money, security measures will protect your transactions and prevent others from stealing your items. By focusing on these quality attributes, game developers create games that are not only fun but also reliable, easy to use, and secure, providing the great experience for players. Quality attributes considerations. Now, this is specific topic that there are three problems with various discussions in the quality attributes. The definition provided for an attribute are not testable. It is meaningless to say that the system will be modifiable. Endless time is wasted on arguing over which quality a concern belongs to. Is a system failure due to denial of service attacks? An aspect of availability, performance, and security and usability. Each attribute community has developed its own vocabulary. A solution to the first two of these problems, untestable definition and overlapping concern, is to use quality attribute scenarios as a means of characterizing quality attributes. A solution to the third problem is to provide a discussion of each attribute, concentrating on its underlying concerns to illustrate the concepts that are fundamental to the attributes community. Specifying quality attribute requirements: stimulus source, response measure, environment, and artifact. So specifying quality attribute requirements in computer gaming as our running example. When developing a computer game, it is important to set clear goals for how well the game should perform, not just what it should do. These goals are called quality attribute requirements and they help ensure the game is enjoyable and meets players' expectations. For example, quality attributes requirement for performance might specify the game should run at 60 frames per second to ensure smooth animations and quick responses to player actions. This means the game will feel responsive and look smooth, making it more enjoyable to play. Reliability requirements are also crucial. They might include ensuring the game crashes less than 1% of the time and that it can recover gracefully from errors without losing the player's progress. For instance, if the game saves your progress automatically every few minutes, you won't lose much if the game crashes. Usability requirements focus on making the game easy to learn and play. This could involve specifying the game's controls should be intuitive with clear instructions and user friendly interface. For example, a requirement might be that the player can start playing and understand the basic controls within the first 5 minutes of the gameplay. Security requirements are essential, especially for online gamings. These might include ensuring the player's data is encrypted and that the game has protections against hacking and cheating. For example, a requirement could be that all communications between the game and its servers are encrypted and protect players' personal information. By specifying these quality attribute requirements, developers can create games that not only have exciting features but also perform well, are reliable, easy to use, and secure, providing a great overall experience for the players. Specifying quality attribute requirements and tactics. We'll continue the example of computer gaming. To make a computer game successful, developers use specific tactics to achieve the desired quality attributes. These tactics are practical steps taken during development to ensure the game meets its performance, reliability, usability, and security goals. For example, to achieve good performance, developers might use tactics like optimizing the game's code to run efficiently on different hardware. These could involve reducing the complexity of graphics or improving how the game uses the computer's processing power, ensuring it runs smoothly even on less powerful devices. Reliability can be achieved through tactics like thorough testing and implementing error handling mechanism. Developers test the game extensively to find and fix the bugs that could cause crashes or glitches. They also add features that allow the game to recover from errors gracefully, such as automatic save points or the ability to resume from the last checkpoint. This ensures that players have a smooth and uninterrupted gaming experience. To enhance usability, developers use tactics like designing intuitive user experience and user interfaces and providing clear instructions. They focus on making the game's control easy to learn and use, ensuring that players can quickly understand how to play. Additionally, you might include tutorials or help sections to guide players through the game's features. This makes the game accessible and enjoyable for both new and experienced players. Security is achieved through the tactics like implementing encryption and anti cheat measures. Developers use encryption to protect players' personal information and game data from being accessed by unauthorized individuals. They also implement anti cheat systems to prevent players from using unfair advantages. Ensuring a fair and enjoyable gaming experience for everyone. By employing these tactics, developers can create games that not only having exciting features but also perform well, are reliable, easy to use, and secure, providing a great overall experience for the players. We distinguish general quality attribute scenarios like general scenarios, those that are system independent and can potentially pertain to any system, from concrete quality attribute scenarios, concrete scenarios, those that are specific to particular system under consideration. For example, general scenarios for availability. The source is internal, external, people, hardware, software, physical infrastructure, physical environment. The stimulus is the fault, omission, crash, incorrect timing, incorrect response. Artifacts can be processors, communication channels, persistent storage processes. Responses prevent fault from becoming failure, default, detect fault, log, notify, recover from fault as disable, event source be unavailable, fix, mask, degrade, degraded mode. And the response measured as time system must be available. Availability percentage, time is degraded. Mode, repair time, proportion of fault system handles. Okay, achieving quality attributes through tactics. So let's look into this with a little bit more depth. There are a collection of primitive design techniques that an architect can use to achieve a quality attribute response. We call these architectural design primitives tactics. As I just discussed earlier, tactics like design patterns are techniques that architects have been using for years. We do not invent tactics, we simply capture what architects do in practice. Why do we do this? There are three reasons. Number one, design patterns are complex. They are a bundle of design decisions, but patterns are often difficult to apply as is. Architects need to modify and adapt them. By understanding tactics, an architect can assess the options for augmenting an existing pattern to achieve a quality attribute goal. If no pattern exists to realize the architect's design goal, tactics allow the architect to construct a design fragment from first principles. By cataloging tactics, we make design more systematic. You frequently will have a choice of multiple tactics to improve a particular quality attribute. The choice of which tactics is to use depends on the factors such as trade offs among other quality attributes and cost to implement. Guiding quality design decisions. There are seven of these. Architecture design is a systematic approach to making design decisions. We categorize the design decisions that an architect needs to make as follows: allocation of responsibilities, coordination model, data model, management of resources, mapping among architectural elements, binding time decisions, and choice of technology. So if we continue our computer gaming software design, a software model, and all that jazz, making a great computer game involves more than just coming up with fun ideas. It requires careful planning and decision making to ensure the game meets high standards of quality. Guiding quality design decisions means choosing the best approaches and features to make the game perform well, be reliable, easy to use, and secure. For example, when designing a game, developers must decide on graphics style and how detailed the visuals should be. This decision affects the game's performance as more detailed graphics require more processing power. Balancing visual quality with performance ensures the game runs smoothly on various devices. Reliability is another key factor in quality design decisions. Developers must decide how to handle errors and unexpected issues in the game. This might involve implementing automatic save points or checkpoints so players don't lose progress if the game crashes. It could also mean including robust error handling code to prevent a game from freezing or crashing. These decisions ensure that the game is stable and provides a consistent experience for the players. Usability is crucial for making a game accessible and enjoyable. Design decisions here focus on creating intuitive controls and user interfaces. Developers must decide how to lay out menus, how to present information to players, or how to make the game's controls easy to learn. This might involve conducting users' tests to see how players interact with the game and making adjustments based on their feedback. By prioritizing usability, developers ensure that the players can easily navigate and enjoy the game. Security is also an important consideration in quality design decisions. Developers must decide how to protect players' data and prevent cheating. This could involve implementing encryption for data storage and transmission, as well as anti-cheat measures to ensure fair play by making security a priority. Developers create a safe and trustworthy gaming environment for all players. In summary, guiding quality design decisions involves carefully considering performance, reliability, usability, and security by making informed decisions and choices in these areas. Developers can create games that not only have exciting features and but also have uh, are providing high quality experience for the players. Allocating responsibilities, decision involving allocation of responsibilities include identifying the important responsibilities, including basic system functions, architectural infrastructure, and satisfaction of quality attributes. Determining how these responsibilities are allocated to non runtime and runtime elements, namely module allocation to non-runtime and runtime elements. Modules, components, and connectors are part of the important decisions. The coordination model. So the decision about the coordination model include identify the elements of the system that must coordinate or are prohibited by coordinating, determining the properties of the coordination such as timelines, currency, completeness, correctness, and consistency, choosing the communication mechanism that realize those properties. Important properties of the communication mechanisms include stateful versus stateless, synchronous versus asynchronous, guaranteed versus non-guaranteed delivery, and performance related properties such as a throughput or an latency. Data model. Decisions about the data model include choosing the major data abstractions, their operations, and their properties. These include determining how the data items are created, initiated, accessed, persisted, manipulated, translated, and destroyed. Metadata needed for consistent interpretation of the data. Organization of the data. This includes determining whether the data is going to be kept in a relational database, a collection of objects, or both. Management of resources. Decisions for management of resources include identifying the resources that must be managed and determining the limits for each, determining which system elements manage each resource, determining how resources are shared, and the arbitration strategies employed when there is a contention, determining the impact of saturation on different resources. Mapping among architectural elements. Useful mapping include the mapping of modules and runtime elements to each other. That is, the runtime elements that are created from each module, the modules that contain the code for each runtime element, the assignment of runtime elements to processors, the assignment of items in the data model to data stores, the mapping of models and modules and runtime elements to units of delivery. The binding time. The decisions in other categories have an associated binding time decisions. Example of such binding time decisions include for allocation of responsibilities, you can have build time selection of modules versus parameterized build script. For choice of coordination model, you can design runtime negotiation of protocols. For resource management, you can design a system to accept new peripheral devices plugged in at runtime. For choice of technology, you can build an app store for a smartphone that automatically downloads the appropriate version of the app. Choice of technology. Choice of technology decisions involve deciding which technologies are available to realize the decisions made in other categories, determining whether the tools to support this technology, IDEs, integrated development environments, simulators, testing tools, etc., are adequate, determining the extent of internal familiarity and external support for the technology, such as courses, tutorials, examples, availability of contractors, determining the side effect of choosing a technology such as required coordination, model, or constrained resource management opportunities, determining whether a new technology is compatible with the existing technology stack. To summarize this entire lecture, requirements for a system come in three categories. Functional is these requirements are satisfied by including an appropriate set of responsibilities within the designs. Quality attribute, these requirements are satisfied by the structures and behaviors of the architecture. The constraints, a constraint is a design decision that is already being made. To express quality attributes requirements, we use a quality attribute scenario. In the discussions we have conducted in this lecture on software architecture covered several key aspects essential for creating robust and efficient systems, particularly in the context of computer gaming as we took as our running example today. We explored the fundamental concepts of software architecture which act as a blueprint for how different components of a system interacts. Using gaming example, we highlighted the importance of a well-designed architecture that integrates elements like a game engine, user interface, the servers, and to ensure smooth and seamless gameplay. Additionally, we delved into the significance of functionality, which refers to the specific feature and actions in a game offers and how these must be implemented to work flawlessly, providing an enjoyable user experience. We also discussed quality attributes and their considerations in software development. Quality attributes such as performance, reliability, usability, and security are crucial for ensuring that the game not only functions as intended but also meets the expectations of its users. Specifying quality attributes requirements and achieving them through tactics like code optimization, thorough testing, intuitive design, and robust security measures were emphasized. These discussions underscored the importance of making informed decisions, design decisions, to create software that not only features rich but also high performing, reliable, user friendly, and secure, ultimately leading to a superior gaming experience. Happy learning. See you in the next lecture.